All right, this is our last exponent or logarithmic lesson. So now we're moving on to logarithmics that have base e in them. So first of all, you need to know a little bit about what e is and where it comes from. Um, E comes from a number where when you use this formula, which should look familiar to you when we were doing compounding interest, when you use this formula, and you punch in numbers for n. Okay, so you punch in n is 1, n is 2, n is 5, n is 10. And then really, really big numbers. N is 10,000, 1,000,000, 100,000, whatever. You can see that your answers get really, really close to the same number. They get closer, like it's 2.718218 is kind of what it ends up being if you put in n is 100,000. Okay? As n approaches infinity then, y approaches the number e. And so this right here is the number e. And e is kind of like the number pi, where it's an irrational number. It doesn't repeat, it doesn't stop, it doesn't have a pattern to it. But it is a number that goes on forever and ever and ever. And that would be the number e. And e is about 2.718 or so when you do that. So here's what you need to know. It is an irrational number. It is referred to as the natural base. You'll remember in a minute, I think, that you had natural logs, which are ln's. ln's are natural logs. It's referred to as the natural base, used a ton in science and in growth and decay situations, which we will kind of look at some of those over the next couple of days. But if you look at your calculator, there is a button on your calculator to calculate e for you. Okay? It is left of the number 4 key, and it is an e to the x button. And so when you use that e to the x button, is it not going to open my calculator for me, is it? I'll have to do it this way. When you use the e to the x button, that's what that is. It's logs in base e. Okay? You can type in e to the third on your calculator, so use the e to the x button, and when you type in e to the third on your calculator, you should get 20.09 if you do that right. Again, left of the number 4, it's blue and it's above the ln, so e to the third power, and then enter, and you should get 20.09 when you do that. Okay? All right. Then when you're doing the inverse, so you have e to the x is y, and of course y cannot be a negative quantity, we know that. If you were to solve that using logs, then what you would do is it would look something like this. If you have log base e of y equals x, that's what it would look like if you switch it from exponential form to logarithmic form. That's what it would look like. So here's the exponential form, and here's the logarithmic form. Okay? So again, we know that e to the x equals y. So these two equations right here are interchangeable. Okay? So instead of writing log base e, what people do is they replace this log base e right here with ln. So ln is the same as log base e. Okay? It is also called the natural log. Okay? So log base e is replaced with ln, which stands for the natural log. That's what that means. ln is the natural log. Okay? There also is a button, an ln button on your calculator. So if I want you to find ln of 5, you can go right to your calculator if you want, and you can type in ln, which is right next to the number 4 of 5, and it will spit out an answer for you. So ln of 5, if I hit enter, comes out to be about 1.61. Okay, so that's one way to think about that. The other thing you can do if you want to switch this to kind of a different form, we know that ln is the same as log base e. So if I want to kind of make a little equation out of this, I can make this be y, let's say, and then this is logarithmic form. If I want to switch it to exponential form, here's my base, here's my exponent, here's what it's equal to. So you can transform from one form to the other, logarithmic form to exponential form that way. Okay, if you type in ln of e on your calculator, you should get the number 1. And I kind of want to show you why. Okay? Here's why. Again, ln is the same as log base e. And then if I'm trying to figure out what that is right there, I'm going to just make that be x. Well, if you switch this from logarithmic form now to exponential form, here's your base, here's your exponent, and here's what it's equal to. Okay, so obviously the only way that this is going to be equal is, this is a 1 right here, is if x equals 1. So the natural log of e is always 1 every single time. Not a question, don't need to worry about it. Okay? Then the same properties that apply for regular logs also apply for natural logs. So just like when you added two regular logs together, when you add two natural logs together, you can smush them into one log and multiply. Same thing with the quotient, same thing with the power rule. So all of those things apply. All right, if I now have things with a base of e, instead of taking logs, you want to take the natural logs. That's the only thing that's different. Okay, so I have a base of e. I am going to take the natural log of both sides. And of course, all the rules apply. So this exponent right here will come out in front. So I will have x times the natural log of e equals the natural log of 7. This much right here is 1, so I really don't need it. It's 1. So I have x times 1, which is just x, equals the natural log of 7, which then I can type that into my calculator, ln of 7, and x should come out to be about 1.95. Okay, and if I plug it in, it is totally legal for me to take e to the 1.95 and get 7. You can check that. All right, very similarly here. Again, I have base e, so I am going to take the natural log of both sides. I can't get base e and 12 as a power of the same base. That's not going to work, so I'm going to take the logs of both sides. When you have an e in there, you're going to use natural logs instead of regular logs, although regular logs would work too. Again, the exponent out in front makes it look like this. Okay, again, the natural log of e is 1, so I don't really need that. So I have x minus 2 equals the natural log of 12. And of course, x then would be the natural log of 12 plus 2. And make sure you figure out that quantity first and then add 2 to it. Don't take the natural log of 14. That is not going to work. Take the natural log of 2 and then add 2 to it. So x should come out to be about 4.48. And you can check these. That is totally doable and workable and everything. Okay? So here what you want to do is you want to do a little simplifying first. And so in this case, I want to add 7 first. And then I have 5e to the x equals 2 plus 7 is 9. Then I want to divide by 5. So I want to get that part, the e part, isolated first before I do anything. And so then I have e to the negative x equals 9/5. Now I will take the natural log of both sides. So I will take the natural log of that and the natural log of that. Of course, this comes out in front. So I have negative x times the natural log of e equals the natural log of 9/5. And of course, we know that the natural log of e is 1, and I don't need that. And now I can just type this into my calculator. So I have negative x equals the natural log of 9/5, or positive x equals negative the natural log of 9/5. And I can type that into my calculator, and I'm going to get about negative 0.588. And again, check that, and you can, that's okay. Negative times negative 5.88, when you plug that in, is not going to break any rules. All right, okay there. All right, now I have it in logarithmic form already, and that's not helping me a whole lot. So when it's in logarithmic form and it's not helping you, then you want to switch it to exponential form, okay? So just so that you can picture this better, natural log is the same thing as log base e, Okay, I always think that that's helpful. Some of you will just skip that step, and if you can skip that step, that is totally great for me. That's fine, I don't care. Some of you need to see that step. So now, here's your base, e. Here's your exponent to the 4 equals 3x. And of course, I have an e button on my calculator, so I can figure out what e to the 4th power is. So then x will be e to the 4th power divided by 3, or about 18.199. Okay? All right, we're getting down there. Okay, and again, this right now is not helping me, so I will divide by 6. And I have e to the 0.8t equals 4/6, which of course we know is 2/3. Take the natural log of both sides. I probably could skip this problem, but it's okay. I'm going to take the exponent, pull it out in front. Whoops. Okay. Natural log of e is 1. I don't need that. So then I have t equals the ln of 2/3 divided by 0.8. And of course, t comes out to be about negative 0.507. All right. One more and we are good. Okay. This is in logarithmic form still. I'm going to simplify this a little bit. And remember that when I have two quantities that are separated by an addition sign right here, I can smush them together and multiply them. So the natural log of x plus the natural log of 8 is the same as the natural log of x times 8, which of course we know is 8x. On the left side, I can't really do a whole lot right now. But I know that the only way that these two sides of the equation will be equal to each other is if this is equal to this. So I'm going to set that up and then solve it. So I'm going to move that 8x to the other side so that it looks like this. And then I'm going to hope that it factors. And I can get 12 by obviously 3 and 4, 2 and 6. In this case, it'll be 2 and 6. Positive 12 would have to mean it's negative, negative, because of my negative in the middle. So here x equals 2, and here x equals 6. And again, plug those in and check them. Does it make sense? 2 squared is 4 plus 12 is 16. And then right here, if I plug it in, and I plug in x is 2, it works. When you plug in x is 6, it also works. Okay, so plug them in and check them. They both work in this case. Sometimes they won't both work. Okay, that will do it for this lesson.